Hi, and welcome to section 4 of your machine learning course, Improving Model Accuracy. Today, we are going to start the section by reviewing yesterday's assignment. Next, we look at the need to evaluate a model. We look at better measures than accuracy, and we'll understand what these results mean. We will improve a model and finally end the section with an assignment on improving a previous model's review of classifying images using support vector machines. We are going to look at how to solve yesterday's assignment using support vector machines for image classification. To solve the assignment correctly, a first step would be to download the cat versus dog dataset from Kaggle. The dataset downloaded will be in the form of a zip file. We'll extract the zip file into its respective folders for test and train. The train dataset has dog and cat images with dog or cat in the image name, which we are going to leverage while extracting our labels. Next, we label the dog and cat images based on the file name. We then open, resize, and get the features of each image using the pillow library. This will be followed by using the SVM to train a model. We'll find the accuracy and experiment with different kernels and report its respective accuracies. Let's look at Kaggle and download a dataset. This is the dog versus cat dataset available on Kaggle. Here first you log in and then navigate to the data tab. Inside your data tab, you'll download test1.zip and train.zip. I open the cat classification using SVM Jupyter Notebook. We'll create the labels based on the file name. But first, we'll import the necessary libraries, including NumPy, Scikit-learn, Pillow library, and SVM. Next, we'll list all the files inside the train folder and store it in a variable train images. We'll do the same for the test images. We'll then print out the first file name in both test and train. Here you can see that the file name has the noun dog in it, which already tells us that we can use this name to determine our labels. We then use the file names to determine the label. If the file name has dog in it, we'll label it 1, otherwise we'll label it 0. We then extract the features from the images using the pillow library and train our model using SVM. Here we create an empty array called features and instantiate my SVM model. I encourage you to use different kernels and see the results. Here I have used the RBF kernel since it is giving faster results. Next, we'll iterate over all the images present in train images and extract features. To extract the features, first we'll open the image, resize it, filter out all the edges, and then create a histogram out of it. We'll then store it inside our empty features array. We'll then use this features array along with the label to create our SVM model. We then calculate the model accuracy on our first 100 data points. Here, to find out the first 100 data points accuracy, we iterate over the train images, again open the image, resize it, get the features, but instead of training it in SVM model, we use the predict function to predict what our model is going to predict for this particular image. We then store all the results in our results array. We then do a logical AND. So what's happening here is, let's say the first row in labels is 1 as well as the first row in results is 1. It will perform a logical AND and the result will be 1. And then it will count all the ones present in this logical combination and find out the total. Here the total turns out to be 37, which means we got 37 out of 100 images right. We got 37 correct even without any tuning. We'll get better results if we perform some tuning, which is the idea behind this section, and we'll learn more about it in the following section. Let's test it now on unlabeled data. Here, instead of iterating over the train dataset, we iterate over the first 5 images in test. We do the same thing. We resize it, filter it, and extract the features. And we use the predict function to make predictions. We then print out what the predictions are. Here are our predictions. It has predicted that the test image, the first 2 images are dogs and the next 3 are cats. Let's see how it performs. Let's see on the first one. Here I'm showing the image of the first image. Our model had predicted it to be a dog, but it turns out to be a cat. So the first one is not correct. The model got the second one correct. Now let's check on the fifth image. The model have predicted it to be a cat, and it is indeed a cat. So our model got this one right as well. Now again encourage you to use different kernels and report your own results.